Yeah, if they don't read it though. Exam. So I've told you this already. I gave you six word problems, correct? No. 3 optimization, 3 related rates, all together on one little handout, stapled together. Yes. Nope. So on the exam I gave you that. So I told you there will be 1 related rate. I gave you 3. I said there will be 1 related rate, correct? Yes. Okay. Then I gave you 3 optimization. I said there will be an optimization question. People asked me if it needs a formula, like volume or something, will you give it? And I said yes. Okay? So those I gave you, 3 of each. You need to know 1 of the 3. Means you need to know 3 of the 3 because you don't know which one is the 3. Okay. 3. Mean value theorem. I'm going to give you a practice question. So I'm going to give you a mean value theorem question. Shh. So f of x equals x cubed minus x from 0 to 2 using the mean value theorem. Determine the value C. All right. So what we are doing here is the mean value is an average, correct? So what you have to do is you are going to, you could do 0 to 2, you could do whatever you want for the mean value theorem. So you're going between 0 and 2, and we could go, so we can go f of 0 equals what? 0 cubed minus 0, which equals 0. And then f, you were doing rolls, Brooke, you were doing rolls here. You were trying to find the 2 x's, 2 y's that were the same, and then say that there's a maximum in between. That's rolls theorem. Mean value theorem is that there's a slope at the same rate. So mean value theorem, if I went to sketch this graph between 0 and 2, I'll show you what it looks like. So between 0 and 2, we have a graph that goes through 0, 0. Yeah. 0, 0, 1, 0, 2 and 6. And then it has a minimum. At 0.5 and negative 0.3, somewhere down here. So the graph is doing this, correct? Do we agree? The graph between 0 and 2 is doing that. The mean value theorem states that there is a C somewhere along here that will result in, I'm going to make sure it's different color, the same slope as these 2 connected. So these 2 connected give me a slope like, and that's a straight line, like that, correct? Yep. We're trying to find the C, some x, where the tangent slope runs at the same value as that line. We're trying to find the x that's going to result in that. So our formula is f for the mean value theorem is f prime of c equals f of b minus f of a all over b minus a. So you're trying to find some tangent slope. This is tangent slope, correct? some tangent slope that is equal to the slope between those 2 points that I gave you, those two x values. Okay? So, I do f of 0 is 0, f of 2 is 2 cubed minus 2, which is 6. So I have a coordinate at 0, 0, and I have a coordinate at 2, 6, and I can get slope x1, y1, x2, y2 with those. So I'm going to go f prime of c, I'll leave in a second. I'm going to go 6 minus 0 over 2 minus 0. And then f prime of c is literally just get the first derivative, f prime of x, which is 3x squared minus 1, but I want f prime of c, which is 3c squared minus 1. And what's 6 minus 0 over 2 minus 0 the same as? It's a slope of 3, correct? So I'm trying to find a tangent slope, an x value for c, where it's going to give me a tangent slope of 3. So I'm going to get 3c squared minus 1 equals 3. 3c squared equals 4. Divide by 3. C squared equals 4 over 3. Square root, I need to make sure I do plus or minus. So c equals plus or minus 2 over root 3. What is 2 divided by root 3 in a decimal? What is 2 divided by root 3? 1.547. So if I, so if you have it in your calculator, go, do you have the equation in your calculator? You should have the original in your calculator from 0 to 2. Bring up the calculator. I'll show you. So type the original into your y equals. Type the original into your y equals. And restrict your window. Shh. Quiet, please. So in your y1, you have x cubed minus x. Window, 0 and 2. Really? So this is our graph, correct? And we just said one of the c's is at 2 over root 3. Negative 2 over root 3 is outside the domain, so that one's going to be extraneous for us. So if I go second trace value, 2 divided by root 3, I get a dot right here. Now what happens is I have a slope running like this. That's through those points 0 and 2, correct? Not only I could draw this thing. So I have this 3 slope, and if I draw a tangent slope on here, on this dot, right here, it's actually running at the exact same slope as that. That's the c value we're trying to find for mean value here. Okay? So our answer is c equals 2 over root 3, and then c equals negative 2 over root 3. What do we do with it? Circle it, line through it, extraneous. And then this is how most people leave their answers. You guys are really good at rejecting something, but you forget to like, hey, but this is actually the answer. You don't walk through the one, you guys just reject it. Which is great. Okay, I'm going to give you another one to try. So the mean value theorem, once again, is there is a slope between a restricted domain, correct? We're trying to find the c, or the x value, where the tangent slope of that at that point would be the same slope as between those. The a's and the b's. Yeah.
Do you have to find where there's like it equals the two numbers equal each other? So like.
No, that's rolls.
Okay.
Yeah. And the other thing we should have had to state, there's 2 things we needed to state. The graph is continuous and differentiable because the graph is a cubic function, right? You have to state that for mean value theorem. So you guys are trying this one out. So I want you to verify the function's hypothesis, the mean value theorem, find all numbers c, that satisfies the mean value theorem for f of x equals x cubed minus 3x squared plus 2x. Nope, 3x squared plus 2. From negative 2 to 2. You first need to state that it's continuous and differentiable, then do the mean value theorem. So, tomorrow when I ask for mean value theorem, you're immediately going to write down f prime of c equals slope. Shh. F of b minus f of a all over b minus a. You will immediately write that. It's fine. So we find the coordinates at f of 2 and f of negative 2 so that we can get the slope of those. So we're going to get negative 18 minus 2 over negative 2 minus 2, which is negative 20 over negative 4, which is negative 18 minus 2. Dag nabbit, negative 6. Negative 18 minus a minus 2. Okay. Which is negative 16. And then negative 2 minus 2 is negative 4. So we get 4. Then f prime of c. So f prime of x is 3x squared minus 6x. So f prime of c equals 3c squared minus 6c. So this equals 3c squared minus 6c. Before I did any of this, what did I have to do? Yes. So the mean value theorem works since f of x is a polynomial and continuous and differential. So we have a squared. When we have a squared, we have to move everything to one side, set equal to 0, and then factor or quadratic formula. I know, so exciting. Yes? Yeah, but you, as long as you follow the same thing, it doesn't matter. You'll end up with still 4. So I just did y1 minus y2, x1 minus x2. It doesn't matter. No, as long as you always start off with the same one. So if you start off with y1, you have to start off with x1. If you start off with y2, start with x1. Yeah. You just would have gotten positive over positive instead of negative over negative, and would have got 4. Yeah. So 3c squared minus 6c minus 4 equals 0. What multiplies to give me 12 and adds to give me negative 6? Trick question? Nothing. A, B, C. So x equals negative and negative 6 plus or minus the square root of negative 6 squared minus 4 times 3 times negative 4. All over 2 times 3. X equals 6 plus or minus, what's that, 48 plus 36? Isn't it? Yeah, 84. Is 84 reduced? Yes. 21 and 4. So I'm going to get x equals 6 plus or minus 2 root 21 over 6. And then it's a 3 for 1 special. So if you can take it out of all 3 of these numbers, you can do it. If you can't, you don't. So I get 3 plus or minus root 21 over 3. Now the key thing is I just have to check at the end how many of them actually, and I shouldn't have an x, what should I have here? C. How many of them actually fit in the domain, correct? So if I go 3 plus square root 21 divided by 3, I get 2.5. Does that fit?
No.
No. Then I go 3 minus root 21 divided by 3, and I get negative 0.52. Does that fit? Yes. So, C equals 3 plus root 21 over 3. Circle. Cross it out and say extraneous. Just outside the domain. And then we have C equals 3 minus root 21 over 3. So we clearly reject the other one and we keep this because it's inside the domain. Would both of those C's, if we kept the original graph and made the domain bigger, would both of those C's result in the same slope? Technically, but we'd have to make the domain bigger and then we wouldn't be able to have those same numbers, right? So you do have to watch. A lot of the time the one C gets kicked out. Sometimes both will stay, but most often you only get one. And it's not always the positive one, which people try and do. They try and keep the positive of the quadratic formula always. Okay, Rolle's theorem will appear somewhere on the test, but not for marks.
Oh my god.
She just Frenched it. Your Francais bonus. You'll figure that out. All right. Yes. All right. So, we're going to go over what all the things do. F prime of C. F prime of C. Wow. Okay, I'm going to do f of x, then f prime of x equals 0. What does that get me? Critical numbers of the first derivative. What are the critical numbers of the first derivative? What do they get me? They get me max, mins. Sometimes they get me what else? Points of inflection. Sometimes they get me something else. We'll get there. Points of inflection. Sometimes if it's irrational, it's actually a what? An asymptote. Which is why we always, when we do any of these questions, first find our, oops, come on, domain. Donaire tastes better than domain. To be honest, I never ate a domain, but I assume it wouldn't be very good. All right, so if I ask you for max and mins, what am I asking you to find? First derivative set equal to 0. Do I have to find where it increases and decreases to give me my max and mins? Do I have to? I could check the second derivative test. So the second derivative test, what do I do for the second derivative test? I do f double prime of the critical numbers from the first derivative, right? This is to test for, the second derivative test is to literally test if something is a max or a min. We agree? So if f double prime of the critical number of the first derivative is greater than 0, what is it? If it's greater than 0, what is it? If f double prime is greater than 0, it is concave up, which makes me have a what? A minimum. And if f double prime, critical number from the first derivative, is less than 0, it means it's concave down. So it is a max. What if it's equal to 0? Point of inflection. Just guarantees that it actually isn't a max or a min, it is a point of inflection. Okay? So if I ask you for maxes and mins tomorrow, do you have to find the intervals of increase, decrease? No, you can plug it into your second derivative. Sometimes it's easier to find the intervals of increase, decrease because the second derivative is awful. Fine. Right? Like if it's a really ugly product rule or something, it might be easier just to actually find the intervals of increase, decrease. Okay. Now, tomorrow I will give you questions where I literally ask you for just the max and mins. Or I literally ask you for the intervals of increase, decrease, correct? How do I get the intervals of increase, decrease? What do I have to first get? You have to get the critical numbers, which is true. So your first step when I ask you to get the intervals of increase, decrease, is you have to find f prime of x equals 0, the critical numbers. Number 2, you make a number line. And then the increase, decrease will fall between those critical numbers, correct? How do I test it? Where f prime of x is greater than 0, what's happening? The graph is what? Increasing. And where f prime of x is less than 0, it is what? Decreasing. Make sense? So I'm going to give you a equation, and you're going to give me the max and mins, and then I'm going to give you a totally different equation, and I'm going to make you find intervals of increase, decrease. Okay. L'Hopital? Yeah. But L'Hopital is easy. You just differentiate the top, differentiate the bottom.
The limits.
Yes. It's not. You plug in the derivative, you do the derivative of the top and the bottom until it works. Right? So it doesn't give you 0 over 0. All right. So we're doing max and mins, but I want you to find the max and min using the second derivative test. And then this one I want intervals of increase, decrease. Intervals of increase, decrease. And the equation I'm going to give you is g of x equals 5x to the 2/3 minus 2x to the 5/3. So here we have f prime of x equals 4x minus 4x cubed. 0 equals 4x. 1 minus x squared. So 0 equals 4x. 1 minus x, 1 plus x. So my critical numbers are x equals 0 and plus or minus 1. Then I need to find my second derivative, so I can run my second derivative test. So it's 4 minus 12x squared. Okay, so I'm going to plug them in. So I'm going to get f double prime of 0, f double prime of -1, f double prime of 1. So I go, good luck. You're going to do great. You're going to be here for months and months and months. So we get into double, so we go 4, I don't know, I have a bracket. Anyone? So we get 4 minus 12 times 0 squared, which is positive 4. Do I care about the 4? No, I care about the positive. So I know that this is a min. Min, fine. 4 minus 12 times -1 squared. So then I'm going to get -8. I care about the negative, so it is a, let's try this again, max. Cool, it's not changing. Awesome. And then I get 4 minus 12 times 1 squared, which is -8 again. It's negative, so it is a max. So I know I have a maximum at 1 and something. I know I have a maximum at -1 and something. I know I have a minimum at 0 and something. How do I find the something? Plug back into the original. If I'm looking for max, mins, or points of inflection, I always plug back into the original, right? Because it's a point off the original. So if I go f of 0, I'm going to get 2 plus 2 times 0 squared minus 0 to the 4, which is 2. So I know I'm at 0, 2 is my minimum. Then I do f of 1 and f of negative 1. F of 1 is 2 plus 2 times 1 squared minus 1 to the 4, which is 2 plus 2, which is 4 minus 1, which is 3. So 1, 3. Then negative 1 is 2 plus 2 times negative 1 squared minus negative 1 to the 4, which is again 2 plus 2 minus 1, which is 3. So did I have to do any increasing and decreasing to get max and mins? No. Okay? Now a totally different question that's not just a straight up polynomial, because we have to be able to do not just straight up polynomials. I want intervals of increase, decrease, so I'm still going to have to get critical numbers, correct? So I'm going to go g prime of x equals, drop the 2/3 in front, 5x to the negative 1/3, minus, drop the 5/3 in front, 2x to the 2/3. So I get 10 over 3 x to the negative 1/3 minus 10 over 3 x to the 2/3. What do I take out? I can take an x to the negative 1/3 out. I take the smallest one, and I can take out a 10. And if you're like, why is it not 10 over 15? Which is, I know what part of you are thinking. It's because this over 1 and this is over 1, and we multiply numerator times numerator, denominator times denominator, right? So we're going to get 10/3 x to the negative 1/3. When I take that out of itself, I get 1 minus, take the 10/3 out. What's x to the 2/3 take out negative 1/3? X to the 2/3 divided by x to the negative 1/3 is subtraction, right? So 2/3 minus a minus a third, which is 3/3, which is just 1. So I told you this, that if it's x to the 2, x to the 7, x to the negative 4, x to the whatever, x to the pi, x to the whatever, those just result in what critical number? This one. 0. Because you're going to put it equal to 0, 0 to any exponent is 0. So whenever it's fancy, it don't matter. X equals 0 is a critical number, and x equals 1. So I have a number line. Now, is this restricted at all? If you actually type into your calculator, you'll see the domain carries on. Yeah. Because it's a cubic, not a square root. Because you can take negatives and positives of cubes. Oh, it's not a squeeze. Yes, no, forgot about the squeeze. Yeah.
We're making our own language.
Yeah.
I can't forget about
Privatize and squeeze. Continuous.
Or intervals of cavity.
Yes.
Guy would say.
Yes. All right. So, we're plugging in test points, -1, 0.5, and 2. What are we plugging them into? The first derivative, and I often plug them into this. Correct? So we're going to get 10/3 x to the negative 1/3 to the negative 1. Do we care what the actual number is? No. We just care about the what?
Sign.
The sign. Did anyone find them out?
Negative, positive, negative.
Negative, positive, negative. Okay. So we technically, guys, we're technically finding f prime of -1 and finding out it's negative something, right? And then we're finding f prime of 0.5 and we're finding out it's positive something, bless you. And then f prime of 2 and we're finding out it's negative something. Yes? So, wherever it's negative in the first derivative, it's what? Decreasing. Wherever it's positive, it's increasing. So, intervals of decrease are -infinity to 0, union, which means or, 1 to infinity. and intervals of increase, 0, 1. What was the next thing that we found? Points of inflection and intervals of, what did you just say? Intervals of? Yes. I was trying to get you to repeat the same word. Concavity. No. So there's points of inflection and intervals of concavity, which are based off of your second derivative. Shh. Quiet, please. So f double prime of x equals 0 when we have what? They're the critical numbers of the second derivative. They're the critical numbers of the second derivative, and they give us the what? Points of inflection. Or they could end up giving us an asymptote, right? Because but you'll know that because your domain you're going to look at first always. Then where f double prime of x is greater than 0, what do I have? Concave, someone said it? Up or down? Up. F double prime of x is less than 0, it is concave down. All right, I'm going to give you an example. F of x equals 36x plus 3x squared minus 2x cubed. I want the points of inflection and the intervals of concavity. Go. All right. So f prime of x is 36 plus 6x minus 6x squared. And then I say, I don't need you. I just need you to get here. So then I get 6 minus 12x. Because I actually don't care about the first derivative if I ask about concavity, correct? Or points of inflection. You just need it to get the second one. That's it. So 0 equals 6 minus 12x. We can go 6 equals 12x. Divide by 12. X equals a half. We agree? So, it's a polynomial. Because it's a polynomial, we go from negative infinity to positive infinity because domain it is x. We have a half in here. We run our test points. We can go 0, we can go 1. So we do f double prime of 0. Now we plug it in there. 6 minus 12 times 0 is positive. And then I do f double prime of 1. And I get 6 minus 12 times 1, which is negative. So I know that it is concave up from negative infinity to a half. And I know it is concave down from 1/2 to infinity. And I know my point of inflection is at what? 1/2, and how do I get the y? Plug into the original because I'm trying to find a point on the original. Correct? So when I plug it into the original, I get f of a half, which is 36 plus 6 times a half minus 6 times a half squared. So I get 36 plus 3 minus 6 times a quarter, which is 36 plus 3 minus 1.5, which is 37.5. No, I did. It's so disappointing. No. No. Oh, this one's way more work. I don't want to do this one in my head. 36 times a half, which is 18. Plus 3 times 1/2 squared. Squared. Which is 1. Why am I going to such an angle? So 3/4. So 0.75. And then minus 2 times 1/2 cubed, which is 1/8, which is a quarter. Oh, 17.5.
Wow. Sounds good to me.
Sure, we don't want to do it like that.
But,
No, 18.5.
I trust you.
18. Oh, that's an eraser. 18.5. Because 3/4 minus a quarter is a half.
Every day of the week.
All right. We agree?
Yes.
Okay. Last thing I want to go over before La Patel is this. If I give you this, everyone's paying attention because I will lose you. Like you will be lost little souls in Narnia. And there will be no witch wardrobe. Oh, that's terrible. All right. Paying attention. We're all paying attention? Oh, I have an eraser. That's so disappointing. All right. This is f prime of x. Everyone's paying attention. What do we know about f prime of x? We know where f prime of x equals 0, we have what? Critical numbers, which give us what? Maxes and mins. So I know where f prime of x equals 0, I get critical numbers and I get max mins. True statement. Where f prime of x is greater than 0, I get increasing, right? And where f prime of x is less than 0, I get decreasing. And I get that all from a lovely little number line with critical numbers on it.
Yes, ma'am.
All true?
Yes.
Can I turn that graph of f prime of x into a number line? I can. So I'm going to turn this into a number line. What is going to be on my number line? Say this is -3, 1, 4. -3, 1, and 4. Okay, shh. Those are the critical numbers of the first derivative, yes? Because they're where the f prime of x equals 0. So those are my max or mins. So if I ask you from this graph, right, Eric? If I ask you from this graph where the maxes and mins are, they would be one of those three numbers. Or two of those three numbers, yeah?
That would be like max and mins of the original.
Of the original.
Okay.
Yes.
That makes sense.
Not of the first derivative, of the original. Now, what does this represent? Where f prime of x is what? Less than 0, so it is decreasing, correct? That's where f prime of x is less than 0, right? So then from -infinity to 3, I have a negative sign. From 1 to 4, I have a negative sign. Do I not on my number line if I pull that off and make it a number line? Okay. What about these? They're positives. So can you tell me stuff about this graph now? Yes? You can tell me that there are intervals of decrease. From -infinity to -3, or 1 to 4, and there's intervals of increase from 3 to 1, or 4 to infinity. Can you tell me where the maxes and mins occur? If you have increasing, decreasing, you can. What is -3? A min, because what's it doing? Decreasing, then increasing, so it's a min. What about here? Increasing, then decreasing, so it's a max. Then here, min. Can you actually give me the y, though? Where those happen at? No. So they'll ask what x value do max and mins occur. They won't ask for the y. But you can do that. So all you have to do is you have to take, if I give you f prime, you can give me intervals of increase, decrease, and max and mins just because it gives you, just form it into a number line. And if I give you the second derivative, what am I probably going to ask for? Points of inflection, that'll be the x-intercept, and concavity, where the second derivative is above, instead of it being increasing now, That would be concave up. So if this was the second derivative instead, if that was the second derivative, these would be points of inflection. This would be concave down, that would be concave up. Same thing. It depends on what graph I give you, right? If I give you the first derivative or the second. All right, L'Hopital. I think it has one of those. If you get a limit question tomorrow, what do you suppose you're going to have to do? L'Hopital, it's the only thing we did with limits this unit. Now, you can use L'Hopital and other things, but you need to use L'Hopital when you get 0 over 0, right? When you plug it in and you get 0 over 0, you have to do L'Hopital. So when I plug in a 1 here, if I plug in a 1, I'm going to get 0 over 0. Could I do the old way for this one? Could I get x plus 1, x minus 1, cancel them off, and then do that? Yes, I could absolutely do that. Because I would get rid of the problem, right? I would do difference of squares on the top, I take a GCF of an x out of the bottom, the x minus 1s would cancel off, my problem would be gone because it's actually we call it point discontinuity, but in calculus we call it a removable discontinuity, and then it would be gone, our problem would be gone, you can plug in, right? We do direct substitution. But we can do L'Hopital. So, how do we do L'Hopital? Well, you differentiate the top and you differentiate the bottom, not by quotient rule. You legitimately just do the derivative, which is often an easy power rule. Sometimes it's a trig. So, when I differentiate the top, the numerator, what do I get? When I differentiate the denominator, what do I get? Now, if I plug the 1 back in and I get 0 over 0 again, what do I just do? Do it again. But will I get 0 when I plug it in now? No. So I can actually direct substitute. I get 2 over 1 over 2 times 1 minus 1, which is 2 over 1, which is 2. Same answer if I didn't use L'Hopital. So if I went x plus 1, x minus 1 over x, x minus 1, I would get 1 plus 1 over 1, which is 2. Now the catch is, is that sometimes we can't do math with it. We have to do L'Hopital, right? Like this one we could have done both, but not always. All right, so you guys try this one out. Go. So it's going to be limit as x goes to 0 to e to the 2x, that goes away, over cos of x. So we get 2 e to the 2 times 0 over cos of 0, which is 2. E to the 0 is just 1 over 1, which is 2.
Okay. Yeah, I got